Hi everyone, come back. Final exam 1, question 3, projectile motion. Let's see what they ask today. A ball is going up from 25 meters, 12 meters per second initial velocity, and then it's going to highest point and coming down. So, and then passing from door 1.9 meters. Ignore effects of air friction, all right? Question 3.1, define the term free fall. You have 30 seconds now. Please try to write it down somewhere. And the next slide, you are going to see answer, and then you can check your answer. Please try. Define the term free fall. In this topic, they can ask you define the free fall or define the term projectile. One of these they can ask. But now they're asking you free fall. Free fall question. We are answering now. Yes, time is up. Let's show answer for free fall. Free fall, we have two different answers. Motion. Yes, for free fall, you must start with motion. You must say motion, not object. If they ask you projectile, you're going to say object under gravitational force. But now you have motion for free fall. Please just stop video and write it down. Try to memorize. This is our first definition. You can use one of these. Motion in which the only force acting is gravity or weight or gravitational force. You can say second one, look, it looks much better. Motion in which the only force acting is gravity, weight, or gravitational force. Okay, question 3.1, done. Let's continue with next question. 3.2 is coming now, but we're going to separate them. We're going to give your time for 3 to 1, 3 to 2, 3 to 3. Let's start with first one, 3 to 1. Time taken for the ball to reach maximum height. This is our question. Starting from 25 meters and then going to maximum point. You remember our position when object is going to highest point, velocity change to 0. Remember that. And please try to get time to get highest point. You have 30 seconds. We have this equation in formula box. You can have it. V final equals V initial plus A times delta T. We have 4 different formula, but this is first one, which one we can use to get time. You know V final, we know V initial, and the acceleration always constant. Yes, time is over. Let's continue with our answer for 3 to 1. Okay, first of all, for this kind of questions, we are choosing just saying points. Okay, let's use point, initial point and final point. For now, for this motion, I'm using this 2 point. Initial point, let's say point A, and let's use point B. Okay, so initial is A, initial position from 25 meters, and then going to maximum height, point B. For point B, what we know, velocity is 0. Let's say V final equals 0, and V initial is 12, it is given. Time we don't know, but we know acceleration equals 9.8. Negative, and it is going down. We know that acceleration always going down, meter per second square. So, and the direction of initial velocity is up. We know that. And then we are using this formula. V final equals, maybe we can rewrite, V final equals V initial plus A times delta T. I'm choosing this formula from formula box. And then V final equals V initial plus A times delta T. What is V final? 0. You see here also. V final equals 0. V initial is 12. If you say up is positive, you are choosing positive. If you say down positive, it's going to be different story. So it's going to be just negative, positive will be different, rest of them will be same. Okay, so V final equals 0, V initial equals 12. As you see, it's going up because we said up positive. Is it okay? So V initial going up, and then acceleration is minus 9.8. Why? Because we said object is going up, positive. Acceleration we know always down. Okay, for free fall, for projectile motion, acceleration always down, direction down. So as you see, opposite direction. Because of that, we should say negative 9.8. If you use this equation like this, 0 equals 12 minus 9.8 times delta t. From here, you can calculate, and then you are getting 1.22. You can use other options. Maybe downward is positive. If you say downward positive, you're going to write negative 12, because now you are changing direction. You are saying just down is positive. So object is going up initially. Because of that, negative 12, you are saying. And then acceleration is positive because same direction. Acceleration always down, we said. Now positive 9.8, but finally you're getting same answer. Of course, you have different options. You can use other options. I think this question plus minus 10 different options to answer the question, but that was enough. So 3, 2, 1, done. I hope it is clear. Next one, 3, 2, 2. Velocity with which the ball strikes the ground. Okay, velocity when object is going down from initial position. Now this is your final position. When object is touching ground, this is our V final. You are going to try to calculate this velocity. Let's give your 30 seconds for question. Other options you can see for 3, 2, 1. 3, 2, 2 is coming now after 30. Not now, let's give it 30 seconds. Okay. Now you are trying velocity with which the ball strikes the ground. Initial is 12, final is here. You can use this one, you know delta y. So you are going to use another formula. Please try. If you need extra time, stop the video and then try, please. But please try to write it down, your answer, all right? If you do that, it's going to be much better, and then you will get it. If you try, you will learn. So now we are trying to calculate velocity before touching ground. So we are looking for that. Let's see how we are going to calculate it. Now we are using our 2 points. Initial is here, point A. Final is here, point G. For each question, we have to use 2 points. Initial position, final position. All right, please remember that. Now, what I know, but let's choose our direction first. Let's say up, positive. Okay. I'm just choosing up, positive. And then, what is our V initial? V initial equals 12 meter per second. V final, we don't know. We are going to calculate. Delta Y, we know. Initial and final, as you see, change 25 meters, but it's going down. Because of that, delta Y, we are going to say minus 25. Remember that. Let's write 25 for now. 25 meters. And what else we know? Acceleration, 9.8, and then it is going down. So, and then we can use this formula because we don't know time. If you don't know time, you can use this formula. V final squared equals V initial squared plus 2A delta Y. V final, we don't know, we are going to calculate. V initial is 12, and acceleration is minus 9.8, and delta Y is minus 25. And then you are calculating your V final. You are getting positive. You are going to get positive or negative. You are getting negative after this calculation, because just double check 12 squared. Of course, you are getting negative. Because of that, just remove that negative and say downward. Okay, because we said up, positive, and then when you calculate this one, you're getting minus 25,18, and just remove this minus and say downward. This negative is showing you direction. This is our answer. If you say down positive, so now V initial is negative because object is going up initially. Now we set down positive, and acceleration is positive now because acceleration always down, and 25 also positive because object is going down also, and you are getting positive now. positive answer. And positive, what was the positive? Down positive. And then you say down, same answer you are getting. All right. So this is our question 3, 2, 2. As you see, same steps. We are using initial position, final position, and choosing correct formula and calculate. Done. Question 3, 2, 3 is coming now. Please try. Let's see what they ask. Time it took the ball to move from top the door to ground. Okay, now I will give your time for 30 seconds. Oops. All right, your 30 seconds to calculate time from on top of the door to ground. So from this position to down, we are looking for time for this. All right, so delta y is 1.9 now. We initial, we don't know. We final, we know already. We final because we calculate already. You can use different options, but now we are trying to calculate delta t 2, 3, 2 times up. So please try, oh, please just check answer now. If you need extra time, you can stop me and then you can try, you can check. Okay, first of all, AD, what is AD, CD, DG? Just we are lost now. So let's write all points. We are writing down. This is point A. This is point B. We used already. This is point C when object is coming to same level. And then we set for those points D and ground. So if we are using A to D, from A to D, you are using your formula. This is initial point A, final point D. V final up is positive, we are saying. And the V final equals V final, we are going to calculate for this one. And then it's going to be your initial velocity for point D. From D to G, when you calculate, it's going to be initial velocity. So how we are getting that final from A to D? V final square is equal to V initial square plus 2 times minus 9.8, because acceleration always down. We set up positive now, and the acceleration is going down. It is negative 9.8. So, and negative 23.1. Where we are getting this negative 3.1? 25 minus 1.9. This height, 23.1. From A to D, we are going down 23.1. If you are going down, we should say negative 23.1, because from A to D, you are going down. You said positive, up, positive. And you can use from C to D, another calculation if you want, another option. But now your velocity is minus 12 because object is going up and coming down, velocity changing direction. It is negative 12, you should say. But when you get square, so it's going to be same. And then acceleration is still minus because we said positive, up, positive, and negative 23 is plus, minus, same thing. Other calculations from D to G, you can use other calculations, but if we do all of them, you are getting, okay, let's clear them all. Now you know this initial velocity. All right, at point D, initial velocity, V initial is equal to what? 24.43 meter per second. It is going down. And then V final, what about V final? We calculate already, right? Other question, we calculate already. V final is equal to 25.18. V final equals 25.18, also going down. So you know V initial, we know V final, we know acceleration always 9.8 and it is going down. And then let's say up positive, and you can use this formula. V final equals negative 2518, and V initial is 2443. It's also negative because it's going down. Acceleration also negative, and then you are getting delta t. These are answer. Object is moving from D to G. I hope it's clear. We have two steps. Only difference from other questions. This one, we have only one step, but now we have two steps. Step one, you are calculating V initial at point D, and then step two, you are calculating time. That's it. If you want, you can use other options, straight from A to G maybe, but you have to separate. So also we can use two steps, but we have different options, of course. But now we have done question 2, 3, 3, 2, 3. Okay. Let's see what else. We have other options. You are gonna see it. Now they're asking you draw a graph. Okay, draw a velocity time graph, velocity versus time graph for this motion. Start from initial position when it's coming to ground. So clearly indicate, okay, this is important point. If you want to get full mark, you should show on the graph this stuff. Velocity with which the ball was going up, and then time taken by the ball reach maximum height. First calculation, remember question 3, 2, 1. And then velocity when it's coming to ground, final velocity also we should show. Okay, this is our answer now. Oh, we didn't give your time, 30 seconds, but it's too late. Okay, we have done. So now you are going to draw this graph, velocity time graph. Initial velocity is 12. And then coming down, if you say positive, positive up is positive, and 12. And then when it's going up, when object is going up for this position, okay, let's show for this position, 12 meters per second. When it's coming here, change to 0. And then this time is 1.22, question 3 to 1 we calculated. And then object is coming down. Another, they didn't ask, but if they ask, be ready for that. Minus 12 meter per second. Another 122, it means 2.44 seconds. In 2.44 seconds, coming to negative 12 meter per second. Negative 12 meter per second. And then continue, it's going down. They didn't ask you, but if they ask you, you can calculate time for this, and then you can put it here also. But for now, they didn't ask. So this is our graph, velocity time graph. And then if you say down positive, another option for graph, we can show that option also. Let's try to show. Okay, now if you say down positive, first one, initial one is negative 12. So from negative 12 to 0, highest point, and then change to positive. It's going to come down. It's coming down after highest point. All right. So we have done for today, I think. Just double check. Yeah. Question for next lesson. See you next lesson. Good luck. Please try first always.